So, I am trying to put it out in a simple figure. Effectiveness is in the execution, operation, delivery, and efficiency is in designing and implementation of that process. I think I am coming across. Next, please. So, now who should do what? That's the next question comes. So, I can click here. This value-added portion flowing is supposed to be done by the people who actually deliver the work, the value-added. Workman, we call them as workers because they do some work. All others are called something else, not as work, because they don't do any work. That's understanding they have. Okay, so the other one is the supervisors are the ones who are supposed to work on this, reducing and eliminating whatever, non-whatever. And top management's whole single role is only to eliminate the waste. That is how they can try the effectiveness of the organization. It's a very simple figurative presentation, and this is the foundation for all the improvement initiatives we do in Kaizen. Next, please. Some mathematics. So, same thing, putting in the equation form. Process or activity equal to work plus no work, which we call as Mura in the Kaizen language. Next. So, work is whatever I spend for work only is called cost. All other things are called waste. I remember a famous definition by my guru. I have to remember him today. GS. He used to talk about absorption costing. He gave a wonderful definition to me. I just can't forget it. Way back in 1973. 40 years. About 50 years. 50, that words are it. It is absorption costing. He defines as if you have to allocate or apportion every rupee of you spend in the company on every unit of every product you produce, you start dividing any number, come out as any number as a cost. That's called absorption costing. Okay. That's a famous definition that I just can't forget it. Exact words he has used that. So, hence, from that point, all that my spend money is not to be called as a cost. There is a difference between expenditure and cost. Cost is only for the work, and for no work, whatever is spent, don't call it as a cost, it's a waste. Okay, so that's what goes on. So work is, again, next level is further analysis. Work is value added but not value added. Next, please. This is what we are talking about. Expenditure equal to cost plus waste. Next. Cost is again defined further broken down to VA and MBA. Same that slide is in the equation form. Next. So what you have to do, manage the cost by driving efficiency by working on the design. The cost is built in cost is as good as your design. If your design is bad, your cost cannot be better. The cost is designed, and hence I have to drive efficiency by working on the design. Eliminate waste, minimize my MBA, drive effectiveness by smart implementation of processes, execution of operations. Same thing, I put in a word format. Next, please. This is a big slide. I can go on for hours on this one. Quickly, I'll put that one in this area. There are 3 activities happen in every organization, parallel. One is maintaining the current standard or current work. Other one is improving the current standards. Third one is bringing in new standards. These are the 3 activities parallelly every organization has to continue. This has been the basic structure was given by my guru, Sensei Masaki Imai. And we built on that one and tried to understand how I operationalize the concept of it. So what is the current state? Why the maintenance of the current status becomes so difficult in the organization? Because there are enough deviation drivers operating so that I cannot maintain my processes as per design. This is what is the reality. And then, so if I can, those deviation drivers if I can identify and then act upon, prevent it, correct it, whatever you want to do, then you can maintain the current status. That is one. So effectiveness comes in knowing the anticipating the deviation drivers, taking corrective actions or preventive actions, and stay within that design. Second one is improving the current standards by identifying the waste drivers in the current design. It's not that new part, the thing that you are talking about. The current design, how to eliminate the waste by identifying the waste drivers. One of the layout is one of the waste drivers, very famous. Well, that's how we have done the restaurant, put the store somewhere, mineral somewhere, gate somewhere. Then you have people only roaming around, taking the mineral, walking around the factory. That's the design, layout. So those waste drivers you start identifying the design and then start eliminating those waste and bring in new standards. That is improve the current status. Third one is of course bringing a new thinking as you are talking about. Yourself or be creative, whatever you want to do, to bring in new status over there. So these are the three activities which always goes in the organization. There again, it goes back to the same way. By design, you have to drive efficiency by designing and implementation, and you have execution, you have to drive effectiveness. Next please. Now, having dealt on that one in a practical side, I would love to move into the realm of what is smart manufacturing, because the topic is given there, smart manufacturing environment, ecosystem, how we are going to drive. So, why I put that one in the initially is that for driving efficiency or effectiveness, what I should do, where I should do, I must be very clear about it. If I don't know about that one, then there is no question whether it is smart or unsmart or a shabby manufacturing. We can't do anything about it. It is at the design stage and implementation stage, efficiency, effectiveness at the execution stage. If we are very clear about these two points, then in any environment we can apply the term and work on that. So now these are the quick I run through because it's only mostly available in the net, nothing new. Because I have not rushed this one. See why the need for the smart manufacturing has started coming. These are 3, 4 critical problems. Next. These are just a few of the many issues playing. Next. Quickly you can go on. So then there are a period of the Japanese approaches like TPM, Lean, etc. has come, invoking the people power. Invoking the people power and the thereby driving the improving the methodologies and adopting appropriate low-cost technologies, bring out the efficiencies and effectiveness. That was an era. And that has succeeded in certain organizations given the cultural settings in the various places. Then, so after that also has got to become a certain limitation has happened. So one is human know-how and skill is not adequate to handle such a complexity where the manufacturing is and the product designing, product technologies have become more and more complex today. Next please. So today what is happening is a revolution is happening. Industrial revolutions is revolution number 4, 4.4 which you call it as. It is a combination of human know-how, IIoT. We'll be talking about each one, what it is, what this means. Artificial intelligence, data-driven technology, better known as Industry 4.0. That's what is the revolution that is going on. It is sometimes it is used as smart manufacturing, sometimes this, sometimes that. It's all making it together. So computers are trained to spot even the most minuscule faults of the machines. Next please. You can quickly stop there, the slide is and the artificial intelligence we are talking about, marriage of IoT and artificial intelligence gives a different power, and autonomous robots have come which can interact with one another, interact with the human being and learn from the human counterparts and start performing as a human being themselves. These are the things that has been emerging on that one. Next please. the small, so there are 3-4 ways of defining it. I just thought I'd put it, many ways of, no, many people have defined smart manufacturing what it is. I thought of picking up 3-4 on that one. Fundamentally, it's a broad category of manufacturing employees, computer integrated system, etc. All these things are talking about, which all are coming in. And basically, I would love to come on the third and fourth. Smart manufacturing is a discipline in which manufacturing engineers analyze machine and sensor data to improve operational efficiency and avoid downtime. Always somewhere there that has to be understood. That has to be explored. Second one, smart manufacturing is all about harnessing data. Data will tell us what to do and when to do. So it's a data management, data-driven environment, and I think as a profession we must be there if we are not already. Next. So it's a concept, because what is smart manufacturing? It's a concept. The moment I say concept, each one can see the contours can be different for different people. Same item, different concepts, the contours can be different. Basically, it is a combination of certain enablers. I use the word enablers here. It's collectively a manufacturing ecosystem and optimizing entire manufacturing process. What are those enablers? That is, these enablers are generating data. What they do? They generate data, accept data, or both, and analysis done, communicate to the right centers, take corrective action. These are the whole things. Smart manufacturing is all about, again, repeating it, because this is what is critical. Hence, at the cost of repetition, I'm using the same sentence again. Smart manufacturing is all about harnessing data. Data will tell us what to do and when to do. Next, please. So, what are the prominent enablers? It all started with condition monitoring. It's not today. Some 30 years back. Okay, next. Industrial Internet of Things, IIoT. IoTs. I think we're all living with IoT without even realizing what it is. Right? That screen itself is one of the IoT itself. Artificial intelligence, robotics, blockchain technology, and cybersecurity. These are the 6 broad enablers. Of course, cybersecurity is one of the essential to protect the data integrity, but the other 5 are real enablers. So this we have to understand and where we are and do that. Quickly, I'll try to give quick definitions of those things. Next please. It is nothing but monitoring vibrations and communicating to that one, centrally monitoring, sitting in a place, conditions of the machines. This is how it started. The condition monitoring software sending alerts, and it enabled my maintenance team to predict the breakdowns or the machine conditions, and that is the starting point for this revolution. That's what I will perceive it there. Because nothing happens abruptly. There is a continuum. The whole world, the universe is a continuum. If you don't realize that where it is continuing, where the connecting point, then we may miss it out. That may see it as independent. But it's all a continuum. The continuum is the need for the Japanese approaches for people observing and the variations and then taking corrective actions had a limitation. And hence they needed the sophisticated system called condition monitoring. Then it went into the software and it moved on to it. That is the continuous standard. Next please. Then is the IIoT. It is nothing but Internet of Things, IoT. There is Industrial Internet of Things. And each device is connected. This is a very, very critical one. Every device is connected to the chip. Sensors. They collect data, transfer data without human to human or human to computer interaction. That is the most important thing. It communicates without somebody telling communicate. Okay, so then they connect the devices, communicate through gateways, physical servers, etc., etc., and analyze for centralized monitoring. Basically, this whole scheme of things is analysis for centralized monitoring, predictive maintenance of manufacturing infrastructure, operational efficiency, control, and the demand-driven supply chain, etc. These are the areas where this data communication helps. The smart manufacturing, this data collation, data communication, and taking appropriate action after analysis centrally is what is coming up as the core of this IIoT. Next, please. AI, artificial intelligence, because now again, what is intelligence? That's a question. Then when it becomes artificial. How I call a person as intelligent? Because if he is in a position to recall right things, right words, right actions, if he can take, then I call him as intelligent. It is not that something new, something out of the world. Okay. So he is intelligent, but if he does that, what is appropriate? Right. Fine. So similar that right thing and this one is being this one is so hence that intelligence is given to the machine now. Okay, so achetana. The achetana is chetana. That's what is happening over there. So this is the AI will work only if the data is there. If there is no data, no intelligence. No data, no intelligence. For the human being or as well as for the machine. Okay, so AI will work only if the data is available in the ecosystem. Now, of course, in those days, the computing capability, data collection capability were all very poor. That is why we had that allocation of portion to the costing system. It's all in 1940s and 50s. When the computing capability has gone up, still we talk about the apportion of allocation for square feet, drivers and the base of apportionment. I think that means we are not moving out of 1950 and 60. So now it is generate huge amount of data with low cost sensors, store data in low cost system, process data affordable rates. This is possible now. Having that possible, there is one more thing is coming up is the robotics. Robotics is not new. We'll talk about it quickly next slide. With the AI capability, previously